I think it's time that we talk about it. How is DeepMind one of the best AI frontier labs who has been a pioneer in engineering and in solving problems like AlphaGo, AlphaFold? How is DeepMind planning to conquer its path for intelligence, its path to conquer intelligence, its path to AGI, which is artificial general intelligence? So DeepMind is run by Demis Hassabis. He is the CEO and co-founder of DeepMind. He was a child chess prodigy, and he has also academic pedigree in neuroscience, cognitive science, and obviously computer science and machine learning. Right. So what are his plans? So he is targeting AGI with a 50-50 strategy. So as he likes to call it. So he's saying that 50% of the time DeepMind should invest in scaling the existing AI models. Right. We already have large frontier language models and large multimodal models. What if we can spend time investing in scaling laws and investing in scaling these kind of models, right? But whereas he also knows, he also knows that the large models, the large AI models and the large language models are definitely going to be a key component in AGI, right? They might not be the only component, but they are definitely going to be a key component, right? So he wants to invest time, but he also knows that language is not enough. Once you teach a model how to read a lot of text that was there on the internet on all of world's information, and maybe a lot of synthetic text also, synthetic data also, you also want the model to understand other aspects of the universe. What other aspects? The physical and spatial aspects of the universe, right? You also want to you also want to teach the model how to reason like human beings. You also want to teach the model how to trace. You also want to teach the model how to trace its mistake, self-correct, and continually learn, right? So he knows that large language models, large multimodal models are not enough for on all of these grounds, right? So 50% of the time, he's definitely, or DeepMind is definitely going to invest in fundamental AI research, right? So 50% scaling the existing AI models, which might be a key component in AGI, or in making a universal agent that we can call an AGI, right? Now 50% of the time is going to invest in fundamental AI research, right? Fundamental AI research across what dimension, right? So the first dimension that we talked about is continual learning. The second dimension is world models, right? Such models that can understand the physical and spatial dimension of the universe. They know the physics and mechanics of all the objects and gravity and liquids, and they also understand and they also can reason like human beings. So they have the causal reasoning, ability, and they can continually learn. So we call these dimensions as world models, right? We can think about these three dimensions separately, but we can also think about them with respect to calling them world models, right? Or world foundational models. So NVIDIA used to call them WFM, which is world foundational models, and but largely the abstract term that is relevant for this particular dimension is world models, right? World models, continual learning, and it would also cater to physical AI, and then it would eventually join the ecosystem in making up a universal agent, right? Because let's say we have a world model is going to be multimodal, right? And if we have a large language model, we have agentic interfaces around it, we have embodiment, we also have a a humanoid robot that takes instructions from the world model. So the world model acts as the base model for the humanoid robot. We can kind of have a universal agent, right? The whole ecosystem can be called off as a universal agent or an AGI system. Now the main expectation from world models is that they capture the physical dynamics and causality and allow AI agents to learn within that high fidelity simulations before acting in the real world, right? So it's like they should be able to understand the path or maybe a scenario or maybe a discovery before it has happened in the real world. Let me explain, right? So, and why AlphaGo is super relevant here. So we'll talk about two discoveries. One is AlphaGo and one is GENIE, right? So AlphaGo is super relevant for DeepMind and for us and for the AI industry right now, is because not because it could conquer Go and it could win it could win the game of Go, right? But because it is about search and self-correction, right? So AlphaGo had the ability to search and self-correct itself, right? So it basically figured out that it can play with itself, right, to find moves that it has not been trained on, to find moves that humans never thought of, right? So which is basically a new move discovery. So it made a move. There's a movie known as Thinking Game that has been showing AlphaGo, and a move that it made that surprised humans. Humans could never think of that move, right? So it's like a new discovery, right? Obviously, it was a new move discovery. It was not a scientific discovery, but the paradigm is the same, right? The paradigm of self-correction, playing with itself or playing in its own simulation before acting in the real world, right? So when it acted in the real world, it could come up with a new move, right? So this dimension is what we want to take inspiration from, right? And we want to inherit this dimension in models like world models, right? So AlphaGo kind of also proved, right? It proved the hypothesis that an AI agent can surpass human intelligence and come up with synthetic intelligence, synthetic discovery of its own. So that's why we want the world models to inherit these kind of abilities, right? So now what's really happening? So now we have a system known as GENIE, right? GENIE. So GENIE generates interactive environments, right? And it's a generative world model, right? So what it really does is it does not generate simulation environment. So simulation environment, we used to, we used to think about Unreal Engine and, hard-coded physics engine that used to generate simulation environment. GENIE does not generate simulation environment. It generates interactive environment. So the context is always emergent, right? So GENIE has watched, think about this, GENIE has watched hundreds and thousands of hours of videos, right? And then learned that if you drop an object, it falls, right? So basically it has learned the physics or the physical structure and the spatial structure of the universe, right? So now GENIE's environment is better than real videos, right? For an agent. Now, if you want to teach a model, we are using GENIE, right, as an environment generator. So we are now moving from simple text and images and videos to something like environments, right? So a world model, think of world model like this. A world model's responsibility is to learn different environments and represent a 3D interactive environment in a latent space and then learn that latent space, right? So just like large language models used to represent text and tokens in a latent representation or higher dimensional representation like 512 dimensions, 1024 dimensions, right? And then learn those dimensions. Now what this world models are expected to do, they are expected to model or represent these dimensions, sorry, these environments in higher dimension space, in latent space, and then learn that representation, right? So similarly, GENIE is going to help DeepMind simulate thousands and infinite number of environments, and in that environment they can train different AI agents, right? They don't need real videos. They simply can leverage GENIE to simulate a lot of environments, and in that environment an AI agent can go and act in that space and learn in that space, right? So that's how GENIE environment is helping them. So think about world models as athlete, GENIE as a system gym for that particular cohort of athletes, right? So essentially what we are trying to do is we are trying to teach a world model using these interactive environments that are also generated by a system, right? So it's like we kind of teach a model beyond human data, and we are expecting that model to go act in those environments and learn from those environments and do self-correction and discover new pathways, discover new patterns, discover new things that it has not been trained on, right? And also go beyond the human data, right? So all of these mission, coming up with fundamental AI research and coming up with scaling and innovating the existing AI models. So all of these align with DeepMind's current goal and vision to conquer the path to AGI, and it is trying to think of AGI as a meta tool that's going to help in innovate the company and innovate the world in every particular domain. In the next upcoming videos, we will talk more about world models and DeepMind's strategy and Anthropic's strategy to on the path to AGI and these multi-agent systems. Thank you. Cheers.